Hello, this section deals with inverse functions. So, an inverse function is where if you have the function of the inverse, or the inverse of the original function, then you would have an x. What does this all mean? Let's just make it simpler by using an actual example. So, if f of x equals x squared, well, we know if we square root x, then we would have x back. So, our inverse function would then be square root of x. So let's just double check that this works. We have f of the inverse function. So the inverse function is here. And f says that we're going to square anything there. You square a square root, then you're left with an x. So that works. And then, if you have the inverse of a function, well, the original function was squared, and the inverse says that we're going to square root it. You square root the square, you're left with an x. So there you go, that works as well. But sometimes we can't just find it easily. So we need to find a way to counteract these. Not counteract. We need to find a way so that we can find these easily. So, let's just look at it graphically and see what we can do with it. We have y equals x squared and y equals the square root of x. Well, if I put a line right here, you will notice that one is actually an image of the other, and it's across this y equals the x line. What that then means is that the inverse function is an image across the y equals the x line, which means we're just swapping our x's and y's around. Well, if we swap our x's and y's around, all we have to do is just change it when we're solving for it, which I'll do in the next example. But just very quickly, I want you to notice that y equals x squared on this graph. I've only set one single part. There is another part to it, don't forget, because the other part is here. But note that we don't actually do that part, because this only works if we have a function that is 1-to-1 or many-to-1. Okay? So, if we set both parts, then... Sorry, correction, it has to be 1-to-1. Ignore this part. Yeah. So, if we had the other part, however, okay, just to show you, you would end up getting this particular part here, which we know is y equals the negative square root of x, which is completely different. We can't have two different inverse functions, we can only have one. So, you can't have this part, or that part. Which means, when you set it, you have to set a domain such that you only get one part out. So, find the inverse of a function where y equals to 2x plus 3. Well, we know if we set this function here, we only get one answer anyway, so that's fine, we don't have to set a domain. And so, we're going to swap our x's and y's. So we're going to swap our x's and y's here, so we have x equals to 2y plus 3, and then solve for it as per usual. So then we get that. Now the bit on the right, we're also going to interchange our x's and y's, but before we do that, we have an x squared plus 1. Remember, we can only get one single function out. So we are going to set a domain first. So we can either take the positive or the negative side. I'd recommend taking the positive just because it's easier to work with. Now, we have y equals x squared plus 1, so let's just interchange it and see what happens. We'll be left with x equals to y squared plus 1. Okay. Take the 1 over on both sides, and then square root both sides. So then we've got y squared equals to x minus 1. Now, remember when you're square rooting something, you have a plus or minus part. However, because we set that the domain is 0 to infinity, you take the positive part only. Not the negative part. And then if you need to sketch it, once you solve for it, you can sketch it quite easily anyway. Now, If you are, however, not given the particular function, well, it's still quite simple. Remember we said that it is just an image of the y equals to x line. Let's just use that fact to sketch it. So what I want you to do, turn the page so that the function is facing straight up, just to make it easier for yourself, because I need to make it easier for myself. Here's our y equals to x line. And then just simply plot it going on the opposite direction. This looks a lot better than what I did in class. Make sure you label which one's f of x and which one's the inverse of x, otherwise it's hard to tell.